I've spent way too much time on security rules. In fact, it was the topic of my last video. In that video, I probably gave the impression that I had it licked, but I don't, in fact, have it licked. Yeah, my security rules weren't done, but now they're done. I did it by getting very cozy with transactions. And using transactions, I was able to get my data integrity issues under control. And Firestore can be a rat's nest of data integrity issues, because there's no formal structure. So to keep it from getting out of control, I'd recommend getting very comfortable with transactions. Things that seem like a single operation from a user's perspective, in my case, like adding or removing family members from a family, under the hood, that can actually touch like 5 or 6 different tables. And when you add security rules to the mix, it's highly likely that something is going to fail during that multi-part operation. Why? Because it hasn't been tested. It's under development. It's normal for things to fail during development. You test as you go. If you're doing this without transactions, Firestore's data integrity issues are allowed to fester, leaving you with a bunch of data detritus and loose ends. It's a mess. So what transactions do is make it so that if anything fails during these multi-part operations, the entire operation fails. So you don't end up with a bunch of random ass half-complete data all over the place. My one complaint about transactions, however, is that when you fail, I couldn't for the life of me figure out how to tell where in that transaction it failed. So that didn't exactly make debugging a no-brainer. Perhaps that's the nature of transactions, or perhaps I'm just ignorant. My Google searches for how to tell where transaction is failing Firestore Flutter came up with nothing, although I haven't tried ChatGPT yet. So in case you're actually curious what a Firestore transaction looks like in Flutter/Dart, I'll go ahead and show you one of my most gnarly transactions. And that is the part of my code where after a user registers or signs in, the app goes and checks the invites collection for any outstanding family invites. So all you need to do to run a transaction is call the run transaction method on the Firebase Firestore instance, and then put all of your transaction related stuff in this callback. So what's important to note is that you need to use this argument, the transaction object, for doing any reads on which your transaction depends, and you need to use it for doing any writes. And anything that fails within this callback will result in an exception being thrown, which you can catch by throwing an await in front of the run transaction method and then surrounding that with a try statement. Dart's implementation of async await, by the way, is much nicer than Swift's. It's very similar to JavaScript's implementation, which is easier to understand in my opinion. Well, that's it for this video. I'm moving on to implementing email invitations and other such tasks from the to-do list.